Welcome to AD Mathematics, and in this video we are going to look at radical equations. Now this is the last thing that we are going to look at under stairs. I promised you a video where we will solve one example, so don't worry, just stick around. Now what is a radical equation? I'm expecting that you understand a radical equation. When we started defining said, we talked about radical, where we said basically it's just the square root sign any expression attached to it, right? So when you see a radical equation, basically this one you are going to have equation where you are going to get set. That equation is made up of set. Now before you solve radical equations, you have to take note of these steps. Yes, I don't want you to chew this. Don't chew, don't chew. You're going to understand it. We chew it in mathematics, you are going to solve it. We don't choose step. We understand why we are doing certain things. So let's take an example for us to understand our radical equation very well. Let's say we are to solve for x. So we are solving square root of 3x plus 4 and then minus square root of x plus 5 is equal to 1, right? Now the key thing here for solving any equation is to make x the subject. Yeah, so when I give an equation, let's say 2x plus 4 is equal to 8, and I ask you to find x, whatever you do is you are trying to make x the subject, so that after making x the subject, x will be equal to certain expressions. In this case, x will be equal to 8 minus 4 all over 2. And now you will say x is equal to 2, right? Very good. Sorry. Now, so here too is the same thing. The key thing, let me change my pen. The key thing is to make S the subject, right? Now, we already talked about working with set is quite useful here, because if you may recall, in this topic set, when we have the square root of 2, we don't evaluate it. Though when you point it on your calculator, you are going to get 1 point something something something. But when we have the square root of 2, because it's not a rational number, we leave it like so, right? So now, working with square root is quite tedious. So the key thing here is getting rid of the x. Now, how do we get rid of the x? Let's see what the first step is saying. It says group terms containing the sets, right? So now, this is the question. The first thing to do is to make sure that we group the term containing the set, and then we square both sides and simplify. We are squaring both sides so that we eliminate the set or the square root, right? But we've already noticed also that you can never multiply a set to itself, or yes, or a set to any other set for you to get a rational number other than its conjugate. So when you take this, if you want to get this, you have to multiply it by conjugate. Likewise, when we take this, you have to multiply it by its conjugate, right? So someone might be thinking, then let's do that. Let's multiply the conjugate of this expression by the whole thing, and then multiply the conjugate of this by that. But there is a problem which will arise. When we do that, let's try that. We are going to get square root of 3x plus 4 multiplying square root of 3x. No. The conjugate, we don't find the conjugate of this. The conjugate work for sets of the form root of a plus or minus root of b. And this is not in any form. Yeah. So like when you multiply this by itself, basically you are still going to get a set. The same thing, the same way when you multiply this by itself, you are going to get another set, right? So how are you going to get rid of the square roots? The reason, let's group the sets. So now basically, if it is two, if you have two sets like in this, try to group them. Let one set be at the other side of the equation and another set be at the other side of the equation. By doing that, when you square both sides, basically you are going to eliminate it, because we know that square root of a times a is equal to a, right? So that's the only way. We are going to eliminate this square root, right? So we say let's send this set, or yeah, this expression here. So how do you do that in mathematics? So 3x plus 4, and then we transpose, right? So we get 1 plus square root of x plus 5. So that's the grouping. So we've been able to group the cells, one the left hand side of the equation, other and the other side of the equation. Now, what the next step? Square size and simplify this because we are using this property that square root of a squared is equal to a. And if you do that, we'll be able to get rid of the square roots. So let's square both sides. So we square both sides of the equation. We square. Now when we square, what are we getting? Definitely, we are through with this one. This one, the square root will go. So we have 3x plus 4 is equal to, what about this one? Let's expand and see. So we have 1 plus square root of x plus 5. It's the square, it squared means multiplying itself. 1 plus square root of x plus 5. Right. Good. Now let's expand this. We take 1, we take this one, multiply by the whole of this. 1 plus square root of x plus 5 plus we take this one, square root of x plus 5, multiply by the whole of this. 1 plus square root of x plus 5. And this is from binomial expansion. You've not yet done it, but you understand it from junior high school. So let's expand. We have 1 times 1, 1 plus 1 times this one, which is 1 root x plus 5, which I always encourage you to, if it is 1, you can just choose to neglect it. And then plus this 1 times this, we are going to get square root of x plus 5. And then this 1 times this one, square root of a times square root of a, then root a is equal to a, right? So we get plus x plus 5, right? So we can bring this one here, 3 plus 4. I hope you understand that up to this point, right? Yes. So we can group this portion into rational part and then the third part. So when we do that, we are getting 1 plus this one, x plus 5, x plus 5, plus square root of x plus 5, plus another square root of x plus 5. When we simplify, 1 plus 5 is 6. So we have 6 plus x. Hold on. We have 6 plus x. Yes, plus. What is this plus this? I'm getting 2 root x plus 5. Addition of 6. I really hope you understand it. Okay. So now you can say, oh, you see, what's the next step? Now that you square both sides and then you simplify, the question is square again if necessary. And ask yourself, is it necessary for us to square again? Yes, because there is a square root here, right? And the only way we can get rid of it is when it is this expression is multiplying itself. So how do we do that? We have to transpose or send this one here so that the right hand side of the equation will contain this, and then we have both sides to eliminate. So we are sending this one here. We have 3x plus 4, then we send the 6 minus 6. We also send the x minus x is equal to, we have this 2 root x plus 5, right? So let's simplify. I think we have 2x, 3x minus x is 2x. 4 minus 6 is negative 2. 2x minus 2 is equal to 2 square root of x plus 5. I think we can still do something about it. What can we do? We can divide both sides of the equation by 2. So we have x plus 1 is equal to x plus 5. We divided both sides of the equation. This is the expression. And we divided both sides of the equation by 2. So this over 2, this over 2. Now, this one is going to give us 2x over 2 minus 2 over 2 is equal to, this cancel this, right? And this cancel this, that cancel that. So that's the reason why we had this expression. So now we can square both sides again. Let's square both sides. So we have, hold on, this square. So now we have x minus 1 all squared is equal to square root of x plus 5 all squared. What is this expression all squared? We have s, okay, so let me expand it. I know the shortcut I was about using it for the sake of those who don't understand. So, sorry. This will cancel this. So we have x plus 5 here. So now let's expand this. I already told you, you take this one, multiply by the whole of this. Then take this one, multiply by the whole of this. I hope you are really enjoying. Yes. If you don't understand any of the video, go back and get it. So now this time this, we have s squared. This time this, we have minus x. Negative 1 times x, we have minus x. Negative 1 times negative 1, we have plus 1 equal to x plus 5. Okay, so now this is just your quadratic equation. We can send this one here so that like terms will add like terms and then we get a simplified expression. So what's the next step? Let me see. But basically, it's what you are doing. So it says simplify the resulting equation. We check if any or all of these equations. So that step is not necessary. Okay. Where is it going? Sorry. I'm very, very sorry. Yes. So we are here. Okay. So we have x squared minus x plus 1. Then we bring this one here, minus x. We bring the 5 here, minus 5 is equal to 0. Okay. So let's do like 10. This is x squared. There is no squared expression again, right? So we write it x squared. Now minus x is going to give us minus 2x, and there's another minus x here. So it's more like we have minus x minus x minus x, and then we have plus 1 minus 5 is equal to 0. So we say x squared. Here, basic algebra, you will get minus 3x, right? If you reason from first principle like myself, you can see let's factorize x out, right? Negative x out. So you can factorize negative x out. And here you get 1 plus another 1 plus another 1. And then 1 minus 5 is negative 4. It's equal to 0. Okay. Now what do we have? I think okay. Sorry. So now we have x squared minus 3x minus 4 is equal to 0, right? Yes, so here, like we did in the previous video, it's a quadratic equation. Yes, we ask yourself, what two numbers do I multiply to get 4 and then add them to get minus 3? So you have to lay down the factors of negative or of 4. That's when you multiply, you get negative 3. When you multiply, you get negative 4, you get negative 3. So you try to lay down the positive factors first. You can later manipulate them. What are the factors of 4? 1, 2, and 4. But then you have to group them. So 1 times 4 is 4. So you can take 1 and 4. And then what again? 2 times 2 is also 4. 2 and 2, right? So now, can you manipulate this by negating 1 or maintaining this for you to get minus 3? And the answer is yes. When you take 1 and 4, you can see 1 minus 4 is going to give me negative 3. And then this one and then the negative 4, when you multiply, you are going to get minus 4. So we choose that one. So we say x squared. So we choose 1 and what? Negative 4. So positive 1. So plus 1. Then you multiply by x. And then this is negative 4. Negative 4. You multiply by x. And then you bring this negative 4. It's equal to 0. Okay, let me use my white. So I have x squared plus x minus 4x minus 4, right? So you can take these two, and then you can take these two. So here, what are the common factors? X. So you bring x out. X goes into x squared. How many times? It's x. X times x is x squared. Okay. This x divided by this x is what? Is 1 plus 1. Okay. And then here you can say let's factorize minus 4 out. So minus 4x over minus 4 is what? It's going to give us x. Minus 4x over minus 4. This negative 4 cancel this negative 4, leaving x. And now you also have this minus 4 over this minus 4 given as positive 1, so plus 1. Okay, so we see that are like terms, so we can factorize them out. So we factorize x plus 1 out. Now this expression divided by x plus 1, so we have x plus 1 all over x plus 1. What are you getting? X, right? Okay, then we come here. So this expression divided by this x plus 1, so we have minus 4 x plus 1 divided by x plus 1. What do we get? Minus 4. Okay, so is equal to 0. Always I forget, but I remember it's an equation, it's not an expression, right? So on the previous video, we said anytime you have this one, the logic is that either one of them is 0 or both of them are 0. So we see x plus 1 is equal to 0. It implies x is equal to negative 1, or x minus 4 is equal to 0 implies x is equal to 4. So we say x is equal to minus 1 or 4. And we've been able to solve this radical equation. I really hope you enjoyed this lesson. This is the last thing we are doing, and I said, if you have any question, comment in the comment section. Please don't forget to share the video, like and subscribe. The last video I will do on set, I think is we are going to take our time to solve examples and whatever we can. Okay, so see you in the next video. Please share the video, like and subscribe. Bye bye.